thought it was night. That's why. Good evening, good afternoon.
Welcome to winter in the North Country.
Yeah, winter in the North Country. You know, it was worse in Denmark though. This is sunny compared to how Denmark was. I got weird. So what did we cover? I saw one person just shaking their head like, nope. What did we cover a week ago before? Turkeys and cranberries and all of that kind of good stuff. What did we cover?
Rocks.
Rocks. What about rocks?
Igneous, metamorphic and sediment, and then how they each form into one another.
How they each form into one another. What's that process of them becoming one another? Rock cycle. And why should that be ringing alarm bells or bells of mindfulness? Maybe. Now, you shouldn't be panicked. We should definitely be aware. Why are bells of mindfulness ringing in our heads?
It'll be on exam 4 and the
It can be exactly perfect, Seth. It's on exam 4 and on the final exam. Okay, so it's 15 points right there from just that one question. If you memorize that cycle, and that's not a kinda, it's gonna. The definitions in the and the cycle itself will be on the test. That's one question that you know. What's the difference between a rock and a mineral?
All the characteristics.
Characteristics and stuff. Can we get a little more specific? Just a little. What's the difference between a rock and a mineral?
Rock only has to be a naturally occurring solid, whereas a mineral has to have a bunch of other stuff too.
A bunch of other stuff. Excellent. So a rock only has to be a solid and naturally occurring. Minerals have to also have what three characteristics?
Crystalline structure.
Crystalline structure. Excellent.
Definite composition.
Definite composition. So we can write a chemical formula for it. And then what else?
Inorganic.
Inorganic. Excellent. So it has to have those additional 3 rules to make it a mineral. We did an activity together. What activity did we do?
Oh,
Rocks, stuff. I know, it was like a week ago. You're like, oh, there's so much stuffing between then and now.
Minerals.
Minerals. We did the mineral identification, which I noticed I didn't put all the mineral identification trays away. We're not using them. I'll go ahead and grab that from you, Seth, so you have a little more room. But there we go. Thank you very much. So we identified some minerals. So what's one important thing that will help me? One important property that will help me identify quartz as quartz. We talked about properties we needed to know.
6-sided when it grows.
6-sided when it grows. What's another good one? One we tested for. Easy one we can do in the field.
The hardness of it.
Hardness of it. What's its hardness?
Greater than 5.5.
Greater than 5.5. Excellent. What about mica? What helps me identify mica? I will grab a piece of mica back here and pass it around again for refreshing. Refreshing of the mind. This is mica. What helps you identify it as mica? It breaks in sheets. Excellent. Pass that down. It breaks off in these sheets that feel almost like plastic. Excellent.
Don't give it a time frame, it's very flaky.
It is very flaky. I didn't catch the first half of that. Maybe I shouldn't. I don't always want to know what my students are saying. So what's this one right here?
I can't see. Alright. Is it
Iron pyrite. What will help you identify that as iron pyrite? It's gold and shiny. Okay, so it has a metallic luster and it's gold. Now, so does gold. So how do I know this is not real gold and it is fool's gold, other than I have a giant lump of it sitting in the front of classroom at JCC?
test its hardness?
Streak is black. Excellent. Hardness is another good one because it is a lot harder than gold is very soft and this is very hard. But for the ones that we tested and we talked about in class, it's the black streak that helps us identify it. Excellent. Awesome, awesome. And there was like one other thing that I was like, I want to review this before we get started. So it's right in the forefront of the brain. But it doesn't matter because it's not in the forefront of mine. So, oh, quick review of igneous. There we go. Quick review of igneous rocks. We talked a little bit about them. What are the two main groups of igneous rocks? Those are main groups of melted rock. Intrusive and extrusive. Excellent, Abigail. So intrusive and extrusive. How do I tell the difference between an intrusive or an extrusive rock? Have we gone over that?
Is it like the size of the crystals?
It is the size of the
I
crystals.
was doing the homework.
Excellent. Good. Good to hear, Amber.
I wasn't waiting till the last minute for once.
That's spectacular.
I finally learned.
So, it's amazing. So, extrusive. We have smaller no crystals. In extrusive, or intrusive, we have big crystals. And what we mean by big crystals are, you can definitely see that, like if you hold it out with your arm, you can see crystals. That's what we mean by big crystals. When we talk about small crystals, you gotta get really close up to your nose before you see crystals. So we talked about two different kinds of igneous rock, granite and basalt. That reminds me, just to go over another little piece of review that needs to be in the forefront of your mind. Sometimes you can have a rock that's made out of one mineral, right? Like marble. Marble is made out of what? We talked about it last time. It's calcite. Excellent. Now, would it be fair for me to say I found a rock of calcite, or would it be fair for me to say this mineral is marble, even though they're pretty much the same thing? Marble is only calcite. Can I switch those names around? No. Okay, so we have mineral names. So we would talk about the mineral calcite in the mineral calcite in the marble, or we would talk about the rock marble. So keep that in mind when you're studying for the test. Keep those mineral names and those rock names separate. So granite and basalt, are those names of minerals or names of rocks? Those are both names of rocks. So let's make a couple categories of extrusive and intrusive rocks. That we need to know. So I'm going to grab a couple rock samples. This, and this guy over here. So let's start over here, okay? And that's not bird poop on there, even though it kind of looks like bird poop. That is actually from doing acid tests for many years. So this is an igneous rock. I'm telling you that right off the bat. Take a close look at it. Do you see crystals in it? Can you see crystals? No. So do you think it's an intrusive or an extrusive igneous rock? Extrusive. So, does anyone recognize this really dark igneous rock?
Is it obsidian?
Very close. It's basalt. And why is basalt important? Basalt does what? Right on the screen. Not a trick question.
Oceanic crust.
Oceanic crust. Excellent. Excellent, Amber. So, I'm going to put up this guy. Can I see crystals with my naked eyeballs?
Yes. I can't even see it.
I can't even see it right now.
don't even know what's
Doing the color contrast on the Elmo is always a
Like green.
dialing it in sort of a thing.
It look like green.
So do you see any crystals in this guy?
Sort of. It's a little shiny.
So do you see different spots of different minerals in here? Pretty clearly. Yeah. So this guy is an example of big crystals. So, is this intrusive or extrusive? Intrusive. Does anyone recognize this rock? It is granite. Excellent, Leilani. So, granite is an example of an intrusive igneous rock. So what about, I'm going to go send these two bad ones right around, well, they're actually awesome rocks. Send these awesome rocks down the chain. If they collect in the back, that's fine. I just bring them back up to the front. The lab I'm just going to let chaos take its merry course until the end of the semester. So taking a look at this. So you jumped on top of the, Leilani is like, I know that one. That is obsidian. So let's look at this first. What does this look like?
Glass.
Yeah, it looks a lot like glass. Okay. So what kind of crystals does it have? None. It has no crystals. So is it intrusive or extrusive? It's extrusive, and it is in fact obsidian. So I very rarely give a trick or tricky question, but I will do one right now. What minerals are in this? Talk to your neighbor. 10 seconds. Talk to your neighbor. What minerals are in this? Talk to your neighbor. Gain some confidence. Like Caitlin's like, nope.
I don't know.
So, what minerals does basalt have?
Oh yeah.
Are we coming to realizations, epiphanies even?
I don't know.
I don't know, man. Why are you asking me after all that leftovers? So, is anyone willing to give me a guess? What minerals are in basalt? Or I'm sorry, what minerals are in obsidian? Good thought, because I made the glitch, but that was because of the last rock we were talking about. Be bold. Someone be bold. I know I've heard the right answer mumbled a couple of times.
None.
None! Excellent! Parker's got it. So why none?
Because
It's glass, so it has
No crystalline structure.
no crystalline structure. And what do you need for a mineral? Crystalline structure. Excellent. So basalt is an example, one of those great examples of a rock that has no minerals in it. There's not a mineral in basalt, obsidian. Why? Because it has no crystals. Okay? Naturally occurring solid piece of glass. But glass doesn't have any crystals, so there's no minerals in there. Awesome. And then this last one, which is super cool. I'm going to put that up on the screen because I'm feeling like that's a cool one. No dinosaur shopping. Just
She probably would better with see you.
this one's
I had big jars for holding water, but apparently I moved them. That's okay. We have a littler sample. So, anybody recognize the one up on the screen? A lot of you might.
Huh?
Is it pumice? Excellent. Who said pumice? Excellent, Abigail. And where did you see pumice?
You can buy little bricks of it to sand your feet with.
Exactly. So Abigail not only identified pumice, okay, she also pointed out one of its common uses. So pumice is really good for exfoliation, getting dead skin off. So pumice is often used, like for example, for softening your feet. That's one familiar application. Also, if you work with engines, if you ever work with like lava soap, that lava soap, that's where they call it lava soap, because they have ground up pumice in it that helps get absorbed and remove the oils from your skin. Just a second. Some of you might know the cool trick that I'm doing. What's up, Parker?
They also use it when they're hooking up the leads for EEGs too.
They use what?
Pumice.
For what?
Hooking up the leads for EEGs because they have to clean your head. Very
Oh, I
well.
did not know that.
And it's a pain in the butt to get out.
I imagine getting pumice out of your
Hair.
is annoying.
Mhm.
So here's another cool trick. If I got a good sample. Yes! Anyone ever seen pumice do this?
Yeah.
What is it doing?
Yeah.
What's it doing?
Floating.
It's floating.
Oh.
It is a rock.
Oh my God.
It's a rock that's floating. Yeah, it's in water. It's in a jug. It's here.
Why is it because it has
Putting it in the
bubbles?
front of the camera so whoever watches the video, it is floating around.
Is it because it has air inside or something?
Exactly. So pumice is full of teeny tiny bubbles. It's what's known as a frothy glass. In other words, it's basically like a glass sponge with bubbles in the glass.
Look at that.
So we've got pumice. It's glassy, frothy glassy. Vesicular is the technical geologic term for it. So which one is it? Extrusive or intrusive? Extrusive. Excellent. And when there's giant underwater eruptions, you can have huge quantities of pumice coming to the surface of the ocean. There was one time down in New Zealand, this happened about 10 years ago, there was an island made out of pumice, and it wasn't one piece, but there were big chunks of pumice making up this huge island, bigger than the state of Texas, floating off the coast of New Zealand. Yep, they can just float around. And eventually, because pumice, and you'll feel that when you feel the samples, pumice is very soft. It breaks up, the islands break up very quickly, but it's just one of those cool, like, some rocks not only don't have minerals, some rocks actually do crazy stuff like float or catch on fire or stuff like that. So pumice also is another one with no crystals. And now you should be able to answer the question, pumice has no crystals, so what minerals does it contain? None. Excellent. So that's it for igneous rocks. Let's move on to rocks that form at or near Earth's surface. Which group of rocks is that? Excellent. Sedimentary. So, there's a couple different ways sedimentary rocks form. So we break them into 4 major groups. The first major group involves cementing loose clasts, and clasts is a fancy scientific way for chunk. Okay? So cementing loose chunks of pre-existing rock, and that's called a clastic sedimentary rock. So can you think of any rocks that might be chunks of other rocks? Yes. Shale is a great example. So I will grab some. It's been all rocks. I love rocks. So I put it towards the end sometimes just to be like, hey, let's celebrate the end of the semester by talking about rocks. Okay. So one of the rocks that's an example, and it's an unusual example that Leilani brings up as a classic sedimentary rock is shale, because you can't really see the chunks in shale. Okay, the grains are so small, they're basically mud or clay size, and you can't really see it very clearly. Are you exfoliating, Gabriel? It worked for your callus. There you go. That's the power of pumice. Power of geology. We learned this. That mica's used in makeup, whatever. We're learning all sorts of crazy stuff. This is for oil, by the way. This is a very important step. Shales are a very important step for forming oil, which is why they're so dark. They have a lot of what's called organic compounds, little pieces of dead organisms in them, and if they're buried right and heated up right by the earth, they'll turn into oil. So any other rocks that are made of chunks of other rocks that you know the names of?
I feel sad.
Yes.
I don't know.
Sandstone.
Sandstone. Excellent, Leilani. So that one's a little more intuitive, because what are the chunks in a sandstone? It's not a trick question. What are the chunks in a sandstone?
I said sand.
Sand. Excellent. Sandstone. So right here, This right here is a red sandstone. It's made red by iron oxide being present. It had little bits of iron that oxidized. We learned back in Unit 2 what that oxidation is called. What's that oxidation of iron called? Huh? Iron oxidation, or what's the everyday term for it?
Rust.
Rust. So this is an expensive rock because it's rusty. This is a piece of what's known as Potsdam sandstone. It's a common sandstone in this area. Very valuable building material because it's got that bright red to it. So a lot of people use it in facades and that sort of thing. It's an important economic rock resource in the area. And then this one, I just really love this guy. Super easy to see the chunks in it. It's gonna look gross in the overhead. I don't know why it makes it look like teeth, but it does. They're not slimy or anything. It's just the camera. Okay, so it looks slimy, but actually this one's nice because you can actually see the chunks of rock really clearly. And this kind of gravelly rock is called a conglomerate. Pass it on down. So now we have cementing together loose shells and shell fragments. Okay, that's called a biochemical sedimentary rock. Now, can you think of any examples of rocks you may have read about or rocks you may have worked with if you did the extra credit at the end where you did a mini lab? You know the rocks. I know you know the rocks, Leilani. You demonstrated knowing the rocks. Someone's doing the homework. Maybe someone else who is bold can step up. Yes, Kendall.
Limestone?
Limestone. Perfect, Kendall. So limestone is a great example of a chemical sedimentary rock. Apparently at some point I put a little bracket around the tiniest of, what is that, crinoids in there. But you can very often see in this example here, this particular limestone, if you look closely, you can see the fossil organisms that are part of the limestone rock. Now these all had calcite shells. So what's one way I can verify that these are made out of calcite shells? Use acid. Perfect, Abigail. So if I put some acid on this, what do I see?
Fizzing.
Fizzing. I see very active fizzing. So that's limestone. Another cool one. Did I bring it up front here? I don't think I did.
I don't know how to say that.
Yes, I did. So this rock I love for quite a few reasons. Not only is it a great rock, not only is it a great rock for demonstrating how biochemical sedimentary rocks work, because you can see the shells. These are very fresh shells, very loosely cemented together. What's happened is that the calcite in the shells is partially dissolved and then what's called reprecipitated, in other words, recrystallized, and that helps hold these little chunks of shells together. This right here is a very fresh baby, early in stages of the formation of biochemical sedimentary rock called a coquina. This right here is a coquina.
You knew that?
Wow. Isn't that, and it is an excellent Scrabble word. It is a spectacular Scrabble word right there. How many letters are in that? 6. So yeah, you're almost on the way of using all your Scrabble words, and it has a C and a Q, which could be a challenge.
7 words in there. 7 letters.
Are there 7? Did I miscount? I have a degree in math. That's how well I'm doing after Thanksgiving break. That's why I am empathizing with you. So coquina. So biochemical, clastic. Now if we have an accumulation of organic matter, what do you think we call that kind of? Organic, excellent. And when we talk about organic matter, we usually mean plants. A lot of people think that it's fossilized animals or animals building up, but when you talk about the volume of material, plants are the bulk of living things on this planet, and they make up a big part of the rock record. So, can you think of a rock that's, what?
Coal.
Coal, perfect! Amber's got it!
That one I know. I'm excited.
I have a question.
On which one?
No.
I think that's,
I'm thinking that's a trianoid. And I'll probably put it on a test for historical geology.
yeah, picking it out. A lot of them are circled and that kind of stuff, because when I put it out for labs for historical geology, like I have like 12 fossils in there, so I'll highlight one so they can see which one I'm asking about. So, right here, we have coal. It's our best example. And coal is, what determines whether you're going to have coal or whether you're going to have oil is a big chunk by the organism that it's made up of. Coal is made up of dead plant leaves, whereas oil is made up of teeny tiny microscopic dead plants. Okay? So there's a lot more cellulose material here in the coal. And you might be surprised, it's very, very light. It's also not like charcoal. Charcoal is made an entirely different way. Okay, it has to do with heating up wood. Precipitation of minerals dissolved in water. That is called a chemical. Sedimentary rock. And one of the good examples of that not in the direct moment.
I can give you samples.
You can give me samples?
Yes.
I probably have them on the back table over there. So these are different pieces of a type of rock known as a chert. Now chert can also be biochemical, but sometimes it's
Like you got some burnt cheese.
huh?
So this one kind of reminds me of mac and cheese.
Yeah, so usually with the smaller chunks, most people remember it as the oatmeal rock.
Okay. Oh, no, that
So,
one-
because it looks like, they're like, do you have the oatmeal rock? That's the oatmeal rock.
I like the mac and cheese better though. I want to say shirts.
Right?
Okay, so chert is another one, like obsidian. Chert is in the quartz family, so obsidian, if the silica are wandering around and they freeze too quickly, they have no order, they're what's known as a glass. This precipitates very slowly, so you can't see the crystals of the quartz, but they're teeny, teeny, tiny. They're what's called cryptocrystalline. I will go ahead and pass these guys around. Another form of chert is what's known, generally speaking, when we're talking about dark-colored chert, it's flint. Okay?
She says shirt. I think she's saying shirt.
You think I'm saying what?
Shirt.
Shirt?
A dark colored shirt.
Chert. It's my Chicago accent. It's terrible. So, all my R's, when I sing in choir, everyone's like, your consonants are terrifying. They're so hard. I'm like, "Grr." No, I'm not like that. I try to soften my R's. Okay. So, we covered, oh, one last thing I want to show you just because it's cool. Won't show up on the test, but except for maybe as an extra credit. So chert we're using as an example of, I hear a lot of like good people talking just because everybody has an opportunity to pay attention is what I'm trying to say. So we want to keep it to a dull roar. I'm glad that everyone's excited about rocks though. We definitely don't want to squish that. So another cool thing about chert, so we talked about chemical precipitation of chert, okay? So that means that we have the silica that's dissolved in water and gradually it settles out. There's a variety of other chemical sedimentary rocks like travertine, but chert is a really good example. Now, chert, as I'm going to say one more time, can also be a biochemical sedimentary rock. And what's the difference there? What's the difference between chemical and biochemical? Oh, now it got quiet.
Yup.
Yup.
The chemical
What-
is dissolved in water.
Right, it's dissolved in water, whereas biochemical is what? Not, it's animal shells. Okay, right? It's the shells of animals. Now, chert is quartz. In other words, it's basically a form of glass. And you might say to yourself,
Self?
well, self, very well. So, how can living things be made out of glass? So if you take historical geology, one of the things you will learn about is, oop, did I switch the wrong way? There you go. These guys, these are radiolarians. They are teeny tiny organisms that live in the ocean and build these beautiful like castles for themselves, microscopic castles for themselves out of glass. Okay? And there's unbelievable tons and tons of these in the ocean. And they can form biochemical chert when they die and they sink to the bottom of the ocean. So these are all made out of glass. These are living things that live in these crazy little glass structures. And they're part of their shell. They're basically like a part of the organism, like a shell on anything else.